question number 81. Let's read it. If the mass ratio of H2 and CH4 in a mixture is 1:4, then their mole ratio will be. Student, we know that number of moles is equals to given mass upon molar mass. So we have to calculate the molar ratio of H2 and CH4. So number of moles of H2 upon number of moles of CH4 is equals to mass of H2, which is 1. So 1 upon molar mass, which is 2, then mass of CH4, which is 4, upon mass of CH4, which is 16. So 1 upon 2 upon 1 upon 4. That means 2 upon 1. So the correct answer is 2:1. Here I'm writing answer is option number 2. Going to next question, which is question number 82. Let's read it. The volume of CO2 obtained at STP on complete decomposition of 2.1 gram of magnesium carbonate is. Student, let's write the decomposition reaction of magnesium carbonate. MgCO3 on thermal decomposition gives MgO and CO2. Here it is very clear that 1 mole of magnesium carbonate on decomposition gives 1 mole of CO2. We have to identify the volume of CO2 obtained at STP when 2.1 gram of magnesium carbonate decomposes. So student, first of all, let's calculate number of moles of MgCO3 in 2.1 gram. So 2.1 gram upon molar mass. Molar mass is 84 of magnesium carbonate, which is equals to 0.025. Now student, 1 mole of magnesium carbonate gives 1 mole of CO2. So 0.025 magnesium carbonate will give 0.025 mole of CO2 gas. Also, we know that the volume of 1 mole of a gas at STP is equals to 22.4 liter. As a result, the volume of 0.025 mole of CO2 at STP will be 0.025 multiplied by 22.4, which is ultimately equals to 0.56 liter. That means the correct answer is option number 3. Here I'm writing answer is option number 3. Moving to next, which is 83. Let's read it. 44.8 gram of calcium oxide is reacted with 28.4 gram of P4O10. Mass of calcium phosphate obtained in the reaction is. Student, first of all, let's write the balanced equation. So P4O10 on reaction with 6 moles of calcium oxide gives 2 moles of calcium phosphate, that is Ca3PO4 whole twice. Student, here we are given with 44.8 gram of calcium oxide. So let's calculate moles of calcium oxide, which is equals to 44.8 upon 56, which is equals to 0.8. Also, let's calculate the moles of P4O10. So moles of P4O10 is equals to given mass, that is 28.4 upon molar mass, which is 284, which is equals to 0.1. So students, it is very clear that P4O10 is the limiting reagent. It is very clear from the stoichiometry that 1 mole of P4O10 requires 6 moles of calcium oxide. So 0.1 mole of P4O10 will require 0.6 mole of calcium oxide, but we are given with 0.8 mole of calcium oxide. That means P4O10 is the limiting reagent, and we already know that the amount of product formed depends upon the limiting reagent. Here it is 0.1 mole. So here 0.2 mole of calcium phosphate will be formed. So student, mass of calcium phosphate obtained is equals to 0.2 into molar mass of calcium phosphate, which is equals to 310. I've already calculated, which is 62 grams. That means the correct answer is option number 4. Moving to next question, which is 84. Mass percentage of Zn2 plus in an enzyme is 0.2%. The minimum molecular weight of the enzyme is. Student, for this question, let's assume that at least one atom of Zn2 plus must be present in one molecule of the enzyme? Students, for this question we need to know that for minimum molecular weight, each molecule of enzyme should contain one Zn2 plus ion. So 0.2% of Zn2 plus must be present in 100 gram of enzyme. Let's write it. 0.2 gram of Zn2 plus is present in 100 gram of enzyme. So we know that the atomic mass of zinc is 65.4. So 65.4 gram of Zn2 plus is present in 100, divide by 0.2 multiplied by 65.4, which is equals to 32700. That means this is the minimum molecular weight of the enzyme. That means the correct answer is option number 2. Moving to next question, which is 85. Let's read it. Element with atomic number 81 belongs to. Student, for this question, first of all, we'll be writing the electronic configuration of the element, which is atomic number 81. 81 is thallium. The electronic configuration will be xenon, 4f14, 5d10, 6s2 and 6p1. So the last electron enters the p subshell. That means the given element belongs to the p block. So the correct answer is option number 2. Moving to next question.